Okay, so this is the tutorial for the second packet, Angle Relationships Part 1 and Part 2. They're all in one packet. I just didn't expect everybody to finish all of this today, but you may be able to, I'm not sure. So transversal is a first definition. So these are more angle relationships. These involve a line that intersects two or more lines. So the other ones that we had really only involved two intersecting lines. This one's going to at least have three. So it's going to have two lines being intersected by a third line. So in the example in this one, the line that's intersecting the other two would be line T, is our transversal. And then we have some angle relationships that are created when those lines intersect. So if you have two lines intersected by a transversal, there are corresponding angles, which are angles on the same side of the transversal and in the same position. So what that means is, like, let's say if we looked at the left side of the transversal, I should have done that in pencil. So the left side of the transversal, and in the same position. So position relative to the vertex. So for instance, this would be like the top left angle, and this would also be the top left of its vertex. So 1 and 5 are on the same side, and they're both above the transversal, so they would be corresponding angles. Okay, so all of these technically need angle signs, but just to save time, you could just write 1 and 5. I'll do a couple with the angle signs so you know that they're supposed to be there, and then eventually, like, I'll kind of just lose the angle signs for time's sake. Okay, then on the same side, on the left side, these angles that are below the lines, 4 and 8, are both below the lines that they're crossing on the left side of the transversal, so angles 4 and 8 would be corresponding. So corresponding really just means matching positions. Okay, on the other side that I did not circle, there's a set of corresponding, so 2 and 6 are both above the line on the right side of the transversal, so 2 and 6 would correspond. And 3 and 7 are both below their lines, but on the right side of the transversal, so 3 and 7 would be our other pair. Okay, and so that I don't have to write this word out every time, I'm just going to abbreviate this corresponding, C-O-R-R, for the bottom of the handout. Okay, alternate interior angles are interior angles, so they're inside of the parallel lines, or not parallel, sorry, inside of the two lines that are being crossed. They're not adjacent, so they're not next to each other, and they're on opposite sides of the transversal. So let's talk about inside the two lines. So we have 3, 4, 5, and 6 are the options. They cannot be next to each other, so maybe 4 and then something down here. And they're on opposite sides of the transversal. So since 4 is on the left of the transversal, I need to find an angle that's on the right side of the transversal, but it's not next to angle 4. So I wouldn't pick 3 because that's next to angle 4, but 6 will work because it's on opposite sides of the transversal and they're not next to each other. So 4 and 6 would be an interior angle, alternate interior angle pair. And I'm going to abbreviate this in alternate interior for AI. Okay, and the other pair, if I started with angle 3, that's also on the interior. So interior, again, means inside of the two lines that are being transversal. So the only ones that are inside are 3, 4, 5, and 6. So it's got to be, both of the angles have to be inside. They have to make the interior part. Alternate sides of the transversal means one's on the left and one's on the right. So I already did 4, which was on the left. So I'm going to look at 5 now, which is on the left, and pick the one not next to it, because it's got to be not adjacent, not next to it, but opposite of it, opposite sides, so 3 and 5. Okay, alternate exterior is very similar, except for instead of being on the inside of the lines that are being crossed, we're going to be looking at the outside of the lines being crossed. So if I ignore the inside angles, I'm looking at the outside angles, which are 1, 2, 8, and 7. And I want 2 that are on opposite sides of the transversal, so one on the left side of the transversal that's circled, and one on the right side, but not adjacent. So I wouldn't pick 1 and 2, those are linear from what we did before. I would do like maybe 1 and 7. they're on opposite sides, and they're both outside, and they're not next to each other. So 1 and 7, or 2 and 8. Then we have the next kind is same side or consecutive. So next consecutive is in order. So like consecutive wins in a sporting event would be like, that means you had back-to-back wins. No, it's a streak basically. So you have a streak. So same side interior angles. So we want two that are on the inside, on the same side. But again, we don't want them to be adjacent. So we'll put non-adjacent as well. Because if they're adjacent and on the same side, they're technically just a linear pair. Like 3 and 4 are on the same side of the line, so they would make 180. They would be a linear pair. So we're looking interior, but now we want same side of the transversal. So they can't be next to each other because that would be different sides of the transversal. We want them to both be on the left side of the transversal, so like 4 and 5, or both on the right side of the transversals, 3 and 6. So 4 and 5 are both on the left inside, and 3 and 6 are both on the right inside. And then same side exterior is the same thing, but instead of being inside angles, they're outside angles. So I'm going to cover up the inside angles, and I'm looking for the two that are circled. So 1 and 8 are on the same side of the transversal. They're both on the left of transversal T. And then 2 and 7 would be the other option. Okay, so I want you to try these problems. And then we'll check when I get back. So I don't want you to just copy the answers. I actually want you to try it. So 1 and 8, and you would just tell what kind they are. So for this one, I would say 1 and 8. The transversal here is R. The interior angles would be these that are on the inside. These would be my exterior angles. So if I'm looking for 1 and 8 are on the exterior. They're both exterior angles. And one's above the transversal, and one's below the transversal. So I want them to be, for 1 and 8, I want them to be on alternate sides of the transversal, so one above, one below, and on the exterior. When we're doing these relationships, you always need one angle from over here and one angle from over here. You can't have them both on the same vertex. Then if you did, it would become like the vertical or linear that we had before. So we're looking for one to be over here, one to be over here. So 1 and 8 are outside, so they're exterior, and they're alternate sides of the transversal, so different sides, so they're alternate exterior. Again, just look at the top for the abbreviations. It's alternate exterior. Same side interior, I'll abbreviate that SSI for same side interior, or SSE for same side exterior. All right. 2 and 3, they're both interior angles, and they're on the same side of the transversal, so we're looking at same side interior. Okay. So again, you'll try all of those. I'll just tell you how many there are that have no, actually all of these have a relationship from A through F. Yeah. All right, coming down here, what I want you to do for 4 through the end is to identify the transversal first. So this one has a lot going on, so what you want to do is identify the transversal, and it's going to change depending on which angle we're at. So if we're looking at 5 and 13, 5 and 13 are on this vertex and this vertex. Both of those vertex are on line B. So line B would be my transversal. And then I'm ignoring A, essentially, because now I'm going to be looking to see. So this is important because, excuse me, 8, let's look at 8. 8 is an interior angle if you're on transversal B. So if I look at transversal B, 8 is inside of those two lines C and D. But if I'm looking at transversal C, 8 is now an exterior angle because it's outside of A and B. A and B's interior would be 2, 4, 5, and 7. So it does matter what the transversal is if these angles are interior, exterior, or on the same side or not. So for 5 and 13, I'm going to cover up A because 5 and 13 don't involve line A at all. So line B is the one transversing lines C and D. And then 5 and 13 are on the same side of the transversal, and they are in matching positions. So if they're on the same side of the transversal and one's interior and one's exterior, it can't be anything with exterior or interior. So the only option is corresponding or no relationship. But they're both in the top, they're both above their line, and they're both on the same side of the transversal, so this would be corresponding. Okay, if I do another one, 7 and 14. 7 and 14 are also on transversal B because they involve the same two vertex. So 7 and 14 are inside of the line, so they're going to be one of the interior answers. And they're on different sides of the transversal, so we would say alternate. So the word for different sides is alternate. The word for the same side is same side. So these are alternate interior. Okay, if I do one more, 3 and 6. 6 is on this vertex, so I can keep that one circled, but 3 is on this vertex over here. So now my transversal will change to the line that has both of these vertex on it, which is line C. So C is my transversal now. And 3 and 6 are outside, so exterior, outside of the two lines that C is crossing, and on different sides of the transversal, so they'd be alternate exterior. Okay, so try all those on the page. There should be 2 nones on this section. No none exists on this. Then on the back, you just make sure that you can go from, we'll figure out what the transversals are and then name a set of each of these. There's a bunch of different answers, so if you have the exact same answers in the same order as me or as somebody next to you, that probably means you cheated. So please try these on your own. It'll be super obvious for me to tell if you picked all the same ones as me because there's a lot of different options. So 1 and 12, we're looking for what transversal they're on. So 1 and 12 are again on this vertex and this vertex. So I can cover M and I still can see 1 and 12, so my transversal would be L. Alright, so if I just look at L first and then do a trans on L, I can do a set of each of these. So I'm going to look for a pair of corresponding angles on L. It's going to be any two that are in the same position relative to the vertex. So this is in the top above the line. It's the top above the line top, and it's on the right side of the transversal. So 3 would match up with 11. They would correspond. Alternate interior. So we're looking inside of these two lines. This one and this one inside of it. Different sides of the transversal, so like 4 and 9. Alternate exterior now, so we still want different sides, but now we want them to be outside, so like 1 and 12. Same side interior, so we're looking interior, so between these 4. We want them to be on the same side of the transversal. Again, always one from this vertex and from this vertex, so 2 and 9. And then consecutive exterior, so outside angles now, so between 1, 3, 10, and 12, but the same side of the transversal, so like 3 and 12. Okay, and then a non-example would be like 3 and 9. They don't have any relationship. One is outside and one is inside, so it eliminates alternate interior, alternate exterior, same side interior, same side exterior. 4 out of the 5 get eliminated when one's interior, one's exterior. And then they're not in matching positions. This one's on the left of the transversal, this one's on the right. So 3 and 9 would be non-related. So that would be a good example of 2 things that are not related. Okay, so 3 and 9 would be no relationship. It's a non-example. Okay, so try the rest of these. Again, trying it on your own, not just copying your friends or the he, to see if you can understand. Understanding these relationships, which ones are alternate interior and all that, is going to be essential for setting up the equations, just like it was for linear, vertical, and all that. So you have to understand the relationships in order to solve problems. Okay, so then going on to parallel lines and transversals. So if the lines are parallel that are being cut by a transversal, then these different relationships that we just talked about are either congruent, meaning equal in length, or they're supplementary. So if two lines are parallel and they're cut by a transversal, the corresponding angles are congruent, which means the equation would be something equals something else. Alternate interior also congruent, and alternate exterior congruent. So all of these have the equation of something equals something else. If they're same side, either interior or exterior, they're supplementary. Fortunately, we already have experience with these words, so we know the equations for them, or we should start to build on the equations for them. So this is this blank plus blank equals 180 for both of these. Okay. And then from the previous lesson that we did, vertical angles are always congruent and linear are always supplementary, even if the two lines that are being transversed are not parallel, because these things are always true. All right, so what we want to do in these examples is identify if the angle pair is congruent or supplementary. Well, to do that, we need to figure out what kind of angles they are first. So I want you to put the kind that they are, and then congruent and supplementary based off of these. Okay, so our abbreviation for congruent versus supplementary, so equals 180 is supplementary, or congruent is the equal sign with the tilde above it. So I'll write it up here so you can see what I drew. So congruent, remember, means this is our symbol for that. Equal sign with the tilde. All right, so 3 and 5, if we look at those first, 3 and 5 are inside of the two lines and alternate different sides of the transversal. One's on the left, one's on the right. So they're alternate interior. Looking up here, alternate interior are congruent when lines are parallel. Okay, so we're identifying the angle pair as congruent and supplementary, and our reason is that alternate interior angles are congruent when lines are parallel. So since these lines are parallel, and then the parallel part, these arrows are going to tell us that they're parallel. Not arrows at the end, that just tells us that the line extends, but the arrows on the lines tell us that those lines are parallel to each other. Just like with the arc bends, the same amount of arrows tells us which lines are parallel. So if it has one arrow each, they're both parallel. If they both have 2 arrows, these would be parallel to each other. All right, 1 and 8 are exterior, so they're on outside of the parallel lines, and they're on the same side of the transversal, so they're same side exterior, which are equal to 180 or supplementary. So again, this is our congruent abbreviation, and this is my supplementary abbreviation. Okay, so there's some more for you to try on there. And then down here, what you want to do is find out what the measures are actually going to be based on if they're congruent or supplementary. So if we have angle 1 is 65 degrees, we want to figure out what the measures of all of these are and give a reasoning. So what I want you to do is to compare angle 1 to each of these. So you were to compare angle 1 to 2, angle 1 to 3, angle 1 to 4, angle 1 to... So I'll do this one with you, and then there will be some for you to practice. So angle 1 and angle 2. From the lesson last class, these form a straight line, so they are supplementary because they're a linear pair. So that means blank plus blank equals 180, and we already have that this is 65. So angle 2 is going to be 180 minus that, so 115. Okay, angle 3 is across from angle 1, so they are vertical. And vertical are exactly the same, so blank equals blank. So if we have 65 as the first angle, then angle 3 is 65 as well. Angle 4 is this side of the line with angle 1, so they're again linear. So it's the exact same as A. Okay, angle 5 and angle 1 are corresponding because they are both on the same side of the transversal and they're both above their line. So they're in matching positions on the same side of the transversal. So the corresponding, if we come up to the top, are congruent. So we would say that they equal each other. Angle 1 doesn't have a direct relationship with 6. So what we want to do is use something else. This is the only one where you're going to need to use something else besides angle 1. So we already found angle 5, so we could say that angle 6 is going to be linear to angle 5. So angle 5 was 65. So angle 6 is going to be 115. Okay, back to the rest of it. This is the only one again where you have something different than you're comparing to 1. Everything else we're comparing it to 1. That just is important so that if you mess up on number 1, all the rest of them still could be, some of the other ones still could be correct. If you go off of something like if you accidentally calculate this as a 112 and then you started using 2 for the rest of the problem, then everything else will be off. So it's good to start with the one that they give you over and over so that you know at least some of the answers are right, even if you made a mental error before. Okay, 1 and 7 are, what kind do you think? Alternate exterior, because they're outside of the lines, exterior, and different sides of the transversal. So they're alternate exterior, which the equation from the top of this paper is blank equals blank. And we already have 65, so the measure of angle 7 is 65. And then lastly, 1 and 8 are on the same side of the transversal, and they're both exterior, so same side exterior. And those are going to add to equal 180. Okay, so that's how you do the angles. So if I were to put these in here, you should notice that this is an acute angle, angle 1. It's going to be congruent to every other acute angle on this picture. So this is acute, that's less than 90. This is acute, less than 90, and this is acute. All the obtuse angles that are bigger than 90 are 115. And it follows that pattern the whole time. Basically, if I picked this vertex up, if I did my transformation, and I copied this vertex, and then I just moved it, so this was 65, 115, 65, 115, and I just move it right and down to land on this vertex, then these are all 65, 65, 115, 115. So the transformation shows that parallel lines, if they have the same slope, you're just going to have to translate it over and down, and it's the same exact answers for that page. Then there's an example for you to try. Number 3. Okay, then there are a couple examples for 4. So 4, it looks like it's more complicated because there's an extra line here, but really these vertex answers are all going to match. You don't have to tell the reasoning for these, you can just do it. So we'll do a couple together. So measure of angle 5 is 82 degrees. So I already know that there will be all alternate angles as we go down are 82. So basically all the acute looking angles are going to be 82. So this one looks less than 90, so 82, 82, 82, 82, 82, and 82. Then the ones that are next to each other, remember they make a straight angle, they have to total 180. So it's going to be 98 for all the other angles. And then you can just fill those in and you're done. So that one's pretty quick. Okay, when we get to examples 5, 6, and 7, you're going to have to be paying really close attention to which lines are parallel. Because those things that are congruent and supplementary, except for vertical and linear, are only true if they're on lines that are parallel. So for instance, if I look at measure of angle 12 being 121, measure of angle 6 being 75. If I use my trace paper, I can tell, well, first of all, I can get this whole vertex, because vertical angles are the same. Linear pair are supplementary. Okay, so I would expect that this, if I brought it up here, whoops, I need to write the numbers in. So 59, 121, Okay, so these two are still 59, but these two are 121 together. So angles 1 and 2 together make 121, but not by themselves. 5 and 6, same thing. All right, but these are both 59 for 3 and 4. And that makes sense because these are alternate interior. There's no extra transversal crossing them. So 8 and 4 are alternate interior pure. Versus 7 and 5 are not completely alternate interior because there's an extra transversal cutting off this part of the interior angle. So 7 would, this whole thing would be 121, so this whole thing would be 121, but 5 is only a piece of it. So 5 isn't the exact. Oops, probably should have zoomed in. All right, so what we want to look at now is that this is 75, and I know this whole thing, this 75, this has got to be 75 because these are vertical angles. So 121 was the whole thing, and this is 75. I can figure out what 2 and 5 are. So 25 plus 21 would be 46. I don't have much space to write these, but okay. Then the 75 is alternate interior to the 9 here. So these two are on this transversal crossing, so 75 should be 9. And then I can figure out everything else because the vertical are going to match, and then these are going to be their supplements. Okay, then you can fill everything else in. So go ahead and try, you'd have to try 6 putting these in and then figuring out which ones would be congruent, supplementary, and 7, same thing.